Good morning, everyone. I'm Felix, and I'm presenting on the addition of meteorological information to GNSS data processing software, which is a project that has been taken in collaboration with a Geomatic Research and Development Company, which is a spin-off of Politecnico di Milano. Now, the outline of my presentation will run from the introduction through to the conclusion. Now, GNSS, which is an acronym for Global Navigation Satellite System, is based on the observation of satellite signals that travel through and interact with the components of the atmosphere, and is used for positioning and other scientific purposes. And accurate positioning has been possible through appropriate modeling of the interaction of the satellite signals with the ionospheric and then the tropospheric layers of the atmosphere, which causes ionospheric delay and tropospheric delays respectively. Now, the ionospheric delays are caused by the interaction of free electrons in the ionosphere with the satellite signals, while the tropospheric delays is partly caused by the presence of water vapor in the tropospheric layer. And in this session, the focus will be on the tropospheric interactions. Now, at the GNSS receiver station, by processing the observations collected by the receiver, it is possible to accurately estimate the receiver's position in terms of its coordinates, as well as additional parameters accounting for the interactions of the satellite signal with the troposphere. And this technique is known as the precise point positioning method. Now, one software that can be used for processing GNSS data is the GoGPS software owned by Geomatic Research and Development Company, and is implemented based on the MATLAB interface with the PPP technique. Now, it gives estimate of receiver's coordinates as well as the tropospheric parameters, and these parameters, for instance, are the ZTD, that's zenith total delay, zenith weight delay, and the zenith hydrostatic delay. Now, GoGPS also produces plots of those parameters. Now, this is a sample plot that is being produced by GoGPS, and it includes the standard menu items that are found in the MATLAB figure objects, and then the additional export menu item for exporting the figure to other file format that can be used for future purposes, and then an aspect menu item for changing the background color of the figure plot. And it also has an axis plot of the parameter being analyzed. In this case, we have the zenith weight delay, as well as a plot of the number of satellites that were available or visible at the time of observation. And this is also a time series plot of the parameters, that's the zenith total delay in this case, and then the zenith hydrostatic delay. And this plot could be used to analyze the trend of those parameters, which gives an average information about the interaction of the satellite signals with the atmosphere. Now, whilst making the analysis of those parameters from the plot, it might be useful to also know the state of the atmosphere, such as the variability of temperature and pressure, in order to better understand the impact of the atmosphere on the satellite signal, and as well as the parameter being analyzed. And this because the observation station, that's the GNSS receiver station, is exposed to the atmosphere, and the observed signal travels the atmosphere from the space vehicle, that's the satellite, to the receivers. And then also additional events such as earthquake, tsunami, and flood can significantly affect the estimates of coordinates produced by, or can significantly affect the coordinate estimates. And whilst making analysis of variation of the coordinate, it might be useful to know which particular events occurred. Now, the objective of this work was to add those parameters such as humidity, temperature, and pressure to plots produced by the GoGPS that could be used for the analysis, and it involves extraction of weather data from a selected source and displaying it on the plot being produced by GoGPS. And then the second objective is to export the extracted data in a format, that's Rinex Meteorological file format, that could be used also for future purposes. Now the technique that was used is the waterfall approach, which involves these steps as shown on the figure. So we have feasibility, requirements, design up to the maintenance. And the technique involves the completion of a stage before the subsequent stage can be implemented or can be started. And although this technique is used whenever a change in the preceding step is necessitated, that change is initiated or is carried out in order for a complete work to be done. And this waterfall approach has been used instead of the agile method because it was found to be more suitable for the purpose of this work. Now, in the subsequent stages, I'll be describing the various steps that were used in the waterfall approaches. Now, at the beginning of the work, there were a lot of questions that were asked in order to determine the feasibility of the project, such as the possibility to add an image or icon to represent different weather phenomena or events on a plot produced by GoGPS in MATLAB. And then also the possibility to add weather parameters independently, such as humidity, temperature, and pressure to the plot. And then the expected time period needed to complete the entire project. And thanks to the graphical objects available in MATLAB, the project was found feasible to be carried out, although there had to be a trade-off of time in order to attain the full objective of the work. Now, on this figure, I have a hierarchical structure of the graphical objects that were used, and the main ones that were used are the text graphical object, which was used for the representation of numerical data, the surface graphical object for the representation of weather conditions when the length of observation of the GNSS data is less than 30 hours, and then the patch object when is used to represent the weather conditions when the length of the GNSS observation data is more than 30 hours, and then the plot graphical object that is used for representing the parameter being analyzed. Now, at the requirement stage, the must-have and then the should-have requirements were identified. And the must-have requirement, for instance, was that given any receiver position on the globe, it should be possible to obtain its information to be shown on the plot of GoGPS. And also, the program should support display of data for past events. And the should have requirement, for instance, was that the user should be able to hide or show all the parameters at the same time, aside displaying them independently on the plot. Now, at the design stage, the components of the program were identified. And on this figure, I have the identified components. On the left here, I have the components and then their interactions or their dependencies. So the Meteor menu, the figure, and then the data manager, and then the data source. And then on the right, I have the methods and attributes of all these components, of the identified components. Now, for instance, the figure object has the attributes longitude, latitude, starting and ending times that are used for the extraction of the data from the selected source, and then 2D line plots that contain the parameter being analyzed. And then the figure method that called the figure objects for its display. And the data sources that were used include the Dark Sky API for the weather parameters, and then the Open Topo Data API for getting the station elevation or the elevation of the GNSS receiver station that is used in the generation of the Rinex meteorological file. And these data sources are used because they provide data that cover the globe, and they do not require any API key for access. However, in case of failure of these ones, of the identified data sources, these alternative data sources could be used. So for instance, the Google Maps elevation API could be used for getting the elevation data, and then the global surface summary of the day of the National Oceanic and Atmospheric Administration could also be used for getting the weather conditions. And these also are known to the public, and they are sometimes reliable because they are being provided by public institutions that are at least trustworthy. And although these ones could be used, in most of these cases, an API key is required to be purchased before they can be used. And the GSOD also, for instance, requires that its data be first downloaded in a CSV format before it can be used. And this will increase the processing time. That was why the Sky API was used for this project. Now, at the interaction between the identified component is shown in this sequence diagram. Now, in this sequence diagram, for instance, if a user wants to add an item to the plot of GoGPS, the user first selects the Meteor, an item from the Meteor menu component, and then this will activate the add weather info method of the data manager. And at this stage, the longitude, latitude, the starting and ending time attributes of the figure component will be passed on to the data manager, and this will be used to extract the data from the data source. Then the returned data will be passed, then processed, and then displayed on the plot on the figure object. And then finally, the check status of the menu item will be turned on. Now, two main stages were used in the development of the program, which are the preparation of the data, that's removing unwanted characters, because the extracted data was already in an HTML format, so there was a need to remove the unneeded characters from it before being assessed and before being organized in a structure for access and display on the plot. And then finally, a visualization of the data on the plot being produced by GoGPS software. Now, a defensive approach was used at all stages of the implementation in order to handle cases where a user might use the program in an unexpected manner. So, for instance, a user might want to zoom in or out before displaying the weather conditions on the plot. So, it is needed to ensure that in terms of dimension, the icons that are used to represent the weather conditions are displayed correctly at any zoom level. Then finally, the components were integrated into the GoGPS system using this dependency diagram. And here, the light blue boxes represent the components I developed, and then the light green boxes represent the components already existing in GoGPS software. Now, the arrows indicate the interactions between the components, where the starting node indicate the dependent components, and then the ending node indicate the independent components. Of a major importance in the development of a software project is to ensure that the end product meets the needs of the user. And so lots of tests were carried out in order to detect faults in the program and then errors in the program, as well as ensuring that the program satisfies the requirements identified at the beginning of the project, in which case is known as the coverage-based testing. Now, the testing was carried out using a bottom-up approach in the order of unit testing, integration testing, system testing, and then acceptance testing. And this was found to be more suitable for this work as compared to the top-down approach. And the test is carried out using this plan. So, for instance, to display the object on the figure, the test is carried out in this sequence. Now, the data source component is tested, and then the get weather info, get weather condition, and get time zone methods of the data manager components are then tested to ensure that they or give the right amount or the right data needed to be displayed. And then these data are then passed on to the weather info method for testing of that method. And the weather info method display the data on the plots of GoGPS. However, at this stage, the figure itself is not available because the figure is only available at the system level. So a stub of the figure was created, and then finally the figure is tested to ensure that the items are rightly displayed and then they do not overlap on the plots. Now the project will be deployed through the GitHub repository of GoGPS MATLAB. And through daily usage of the program, it is anticipated that additional requirements might evolve. So constant communication will be ensured with JRED for maintenance purposes. However, to reduce future maintenance problems, the techniques of VLET were followed. So for instance, by writing higher quality code at least, and then also anticipating changes during requirement identification, as well as writing less amount of code in order to make future readability of the program easier. Now the results that were obtained. Now on the left, I have the data extracted from the data source and then organized in a structure. And in most cases, these parameters or these fields are almost always found in the extracted data. And then on the right, I have the menu item, and then is the Meteor menu item, and then is sub items that provide access to the end user to be able to display or to be able to add a parameter to the plot produced by GoGPS software. Now this is a sample of the figure object. That's a stub of the figure object that was created that displayed the data for less than a 30-hour period, where icons are being used to represent the weather conditions. And this is for this a sample of the figure stub that was created, and this display data for more than 30-hour period. And in this case, patches are being used to represent the weather conditions with a unique face color for each weather condition. And a legend object is also attached to it for explanation of the face colors that are being used to represent the patches. And this is also a sample of the icons and then the patch, colors that are used for the patches to represent the weather conditions. And this is also a sample of the Rinex meteorological file that is generated, and this contains header information, which is information about the entire file itself, and then the main data for the main data containing the meteorological information. Now the data is read in the order of epoch, which is a year, month, then day, hour, minute, and then second, and then pressure, then temperature, relative humidity, wind azimuth, wind speed, and then rain increments. Now to illustrate the usage of the program, a case that happened at Malpensa Airport on July 13, 2021 was analyzed. And in that case, an Emirates airplane got damaged on its way to John F. Kennedy International Airport, that's New York City, due to adverse weather conditions. And the flight departed Milan at 16:23 but returned at 18:04 hours, with damages on its nose cone and windshields as seen on the image on the right. Now, to have a pre-information of the incident, radar images obtained from Centro Meteo Lombardo were used. And here the radar images were obtained at 30 minutes intervals between 1600 and then 1800 hours. Now from the first image to the last image, we see a cloud colored green, yellow and then red moving towards Malpensa Airport. And this is the Malpensa Airport. Now the colors on the radar image are identified or interpreted using the Hebby table. So for instance, the red regions indicates very heavy rain or hail. And it was not possible to obtain GNSS observation data for Malpensa Airport. So data obtained from surrounding GNSS stations were used for the analysis. And a combined plot of their ZWD were produced after processing the data with GoGPS software. And then the parameters were also displayed on the plots using an approximate coordinate for Malpensa Airport. And here we see during the incident period, we see that the ZWD, that's the zenith delay on the satellite signal due to the atmospheric water vapor content at the time of observation, decreased sharply. And by interpreting it using the information displayed on the plot, we see that during the incident period, which is between 1600 and then 2100, we see there is a sharp change in the direction of the wind from southeast to the northern direction, which indicates instability in the wind movement during the period. And then also we see an increment in the general trend of the wind speed and then the wind gust during the period. So the wind speed, for instance, was 2.6 in the previous day, and then during the incidence period it was 10.2 meters per second. And also by analyzing the humidity and then the pressure values during those periods, we see that those parameters decreased sharply during the incidence period. And this is because as the wind is moving along, it blows the air over the area to the neighboring areas, and this decreases the water vapor content in the area as well as the pressure in the area. And then the weather information during the incidence period is represented with the patch with a face color of light blue, and this is interpreted as rain. And this interpretation also tally with the deduction made from the radar images, in which we see red cloud that is moving towards Malpensa Airport, and which is interpreted from the Hebby table to be rain. Now, the limitation involved in usage of the program is that when displaying data for more than 3 days, the images appear to be clumsy and the display is not nice. So there was a need to perform an adjustment by displaying the data at hour intervals that is equal to the number of days contained in the data. So if the data is being displayed for maybe 10 days, for instance, the items will be displayed at interval of 10 hours. And this is a limitation because it might reduce the it might make a mess of a significant event. So it is suggested or it is recommended that in using the program, it should be used to analyze or to identify where a particular or on which day a particular event occur, and then the analysis will be made for that particular day on which the event occurred so that a detailed analysis can be used, and this would help a lot in order not to miss any significant events. So thank you very much for your attention.